Hello dear students, how are you? Dear students, today we will discuss about cycloaddition reactions. Under this topic, we discuss what are cycloaddition reactions, what are types of cycloaddition reactions, and what is rule of cycloaddition reactions. So, watch the video till the end and don't skip the video. Now, let us start. What are cycloaddition reactions? Cycloaddition reactions are the reactions between two pi systems to form a cyclic product, right? Cycloaddition reactions are the reactions between two pi systems to form a cyclic product, right? The reactions of alkenes and polyenes in which two molecules react to form a cyclic product where pi electrons are used to form a new sigma bond are called as cycloaddition reactions, right? It is clear that in cycloaddition reactions there is reaction between two pi systems, right? One is alkene. We can say that alkene is dienophile, right? And other is polyene, right? Polyene is conjugated diene, right? Generally, HOMO of diene and LUMO of dienophile interact. Dienophiles are electron deficient like electrophiles, so shift of electrons take place from diene to dienophiles, right? I once again repeat, dienophiles are electron deficient like electrophiles, so shift of electrons take place from diene to dienophile, right? These dienophiles are electron deficient, so shift of electron take place from diene to dienophiles. If two pi systems are A and B, means if there is reaction between A and B, right, then cycloaddition is called as A plus B cycloaddition reaction, right? I once again repeat, if two pi systems are A and B, means if there is reaction between A and B, then cycloaddition is called as A plus B cycloaddition reaction, right? Suppose these are two pi systems. If there is reaction between these two pi systems, this reaction is called as 2 plus 2 cycloaddition reaction, right? Why this reaction is called as 2 plus 2 cycloaddition reaction? Because two carbon atoms are in this case and two carbon atoms are in this case. This is ethene, this is also ethene, right? In this case two carbon atoms are there, and in this case two carbon atoms are there. So this reaction is 2 plus 2 cycloaddition reaction, right? If 4 carbon atoms are there, then reaction is 4 plus 2 cycloaddition reaction. This is butadiene and this is ethene. If there is reaction between butadiene and ethene, the cycloaddition reaction is called as 4 plus 2 cycloaddition reaction, right? Very simple concept. Now types of cycloaddition reactions. Cycloaddition reactions are of 5 types. First type is 2 plus 2 cycloaddition reaction or reactions. Second type is 4 plus 2 cycloaddition reaction. Third type is 1,3 dipolar cycloaddition reaction. Then fourth type is cycloaddition reaction of ketenes. This is not ketone, ketene, right? Then last one is chelotropic reaction. Or reactions. These are 5 types of cycloaddition reactions: 2 plus 2 cycloaddition reaction, 4 plus 2 cycloaddition reaction, 1,3 dipolar cycloaddition reaction, cycloaddition reaction of ketenes, and chelotropic reaction or reactions. I write Ca for cycloaddition, so don't confuse. Now preference of cycloaddition reaction. That is, you can say that this is rule for cycloaddition reactions. So what is rule? If number of electron pairs involved in reactions are odd, then allowed cyclization is thermal. If number of electron pairs are even, then allowed cyclization is photochemical, right? This is very simple rule and very important rule for cycloaddition reactions. I once again repeat, if number of electron pairs involved in the reaction are odd, then reaction is thermal. You can say that allowed cyclization is thermal. If number of electron pairs are even, then reaction is photochemical. That means allowed cyclization is photochemical. So this is rule for cycloaddition reactions. Now let us take some examples. Suppose these are two pi systems. This is ethene, this is also ethene, right? So what is the product? Let us see. These electrons shift to this side, these electrons shift to this side. means this bond shift to this side, this bond shift to this side, and we get product like this one. This is cyclobutane, right? This is cyclobutane. Now we can see two electrons involved in these reactions, means these electrons involved in these reactions, and two electrons here, these electrons are involved in this reaction, means two electron pairs are involved in this reaction. It means even number of electron pairs are involved in this reaction. So what the rule says that if even number of electron pairs are involved, then reaction is photochemical. Right? I once again repeat. In ethene, two electrons involved in this reaction, these two electrons. In this case, these two electrons are involved in this reaction, means two electron pairs are there. We can say that even number of electron pairs are there. If even number of electron pairs are there, then reaction is photochemical, right? We take another example. This is butadiene. This is ethene. Now what happens? These electrons shift to this side, these electrons shift to this side, and these electrons shift to this side. We get product like this. This is cyclohexene. Right? If there is a reaction between butadiene and ethene, we get cyclohexene. Now let us see how many electron pairs involved in this reaction. Two electrons, these electrons shift to this side. Two electrons from this ethene shift to this side. Two electrons in this case shift to this side, means 1, 2, 3. 3 electrons pairs are involved. It means odd number of electron pairs are there. What the rule says that if odd number of electron pairs are in reaction, then reaction is thermal. Right? We count only those electrons which take part in a reaction. Right? We do not count these electrons. Right? In this case, 3 electron pairs are involved in this reaction. These electrons shift to this side, these electrons shift to this side, and these electrons shift to this side. Means 3 electron pairs are involved in this reaction. Odd number of electrons are there. What is the rule for cycloaddition reactions? If odd number of electrons are there, then reaction is thermal. Right? So this was all about cycloaddition reactions.